Hello, everybody, and welcome to our today's webinar called The Secret of Smart Hinges. We are glad that more than 70 participants from roughly 20 countries have registered to this event. Thank you very much for your online presence. I guess all of you recognized the two red highlighted letters A and R in the title, as we are going to talk about hinges, which are orientated mainly in augmented reality smart glasses. Now, let me introduce first our team to you. My name is Frank Schröder. I'm responsible for the marketing at OBE. That's me. Then we have Ulrich Wannemacher, very complicated second name.
Hello.
He is head of the R&D department of OBE. And finally, we have another Frank Wienicke, the brain of hinges at OBE, developing since years these small movable parts for glasses, now also for smart glasses. Before we start, here's some general information for you. I will briefly introduce the company and then we will go on with the main presentation by Frank Wienicke. During the whole event, all participants are muted and anonymous. Please use the chat function for upcoming questions during all the time. We will collect the questions and try to answer them at the end of the presentation. If there's no time anymore, we will answer them individually, so nothing gets lost. And now let's get started. I already have the slide. So OBE. We are a key supplier worldwide for the movable parts of spectacles or glasses, having more than 100 years of experience in precision technique, more than 500 employees in Germany and China, and more than 150 patents worldwide related to hinges. OBE at one side. We were founded in 1904 as a tool-making company for the jewelry. The headquarters is in a small village in the Black Forest in Germany, and we are specialized in the production of metal components for eyewear since the beginning of the 1970s. Today, basically, we equip more than 50 million spectacles per year with our standard but also customized hinges. We are one of the market leaders in the optical segment for metal components and the leader for titanium spring hinges. Finally, we have been certified according to ISO 9001 back in the middle of the 1990s. Our vision. Primarily, our first goal is to improve the comfort of glasses with quality spring hinges. Secondly, we aim to increase the lifetime of spectacles with safety screws. Later on, you will receive more information on that. A third pillar on our vision is related to the new market of smart glasses. Here, our goal is to support the function of smart glasses with clever hinge solutions. And generally, we can say that the basic philosophy behind all is to offer long-lasting and sustainable precision components. Our sustainable philosophy has been implemented already since more than 25 years. We have installed an environmental management system with environmental goals for each year, referring to the reduction of energy, waste, water, and generally the optimization of resources. If you remember, we sent you a questionnaire regarding important features for your smart hinges. Thanks to all of you for your answers. With your help and our expertise, we summed up the main features of hinges in smart glasses. And these are called the so-called secrets of smart hinges. Secret number one is weight. As smart glasses are usually heavy, the hinge can help to lighten the glasses. For instance, with a lightweight material like titanium. For sure, the hinge is not the major originator of the weight of the total frame, but remember, every gram or ounce counts. Secret number 2 is comfort. Smart glasses should be kept in position on the wearer's head. But if they're too tight, smart glasses can cause easily headache. A good hinge can contribute to optimize the pressure on the wearer's head by creating comfortable feeling. Secret number 3, good movement. Hinges are the testimonials or the references for a quality spectacle. More than often it happens that temples do not stay in position. They tend to become floppy after a while. It is important to know that hinges and the relevant screws can regulate the articulation, but how, you will learn soon. Secret number 4, durability. Smart glasses are not always on the wearer's head. They maybe are put on and off on a regular basis. The correct hinges for your smart glasses can influence the lifetime of the smart glasses. Let's see how our robot, Robert, tests the glasses. We use this robot often in fairs. Secret number 5, exchangeability. Smart glasses are expensive, and exchangeability of the hinge is important to maybe replace easily the electronics or the cable. In this case, it is important that hinges facilitate the repair and handling in the temple area. Secret number 6, data transfer. In the webinar, we are going to differentiate hinges which are more appropriate for independent solutions or temples which do not communicate to the front part of the frame, and those where data transfer is necessary. In the second case, hinges play a major role for a perfect functionality of data transfer. So Frank is going to present now different hinge solutions for smart glasses. At the end of each chapter, we will evaluate the category and emphasize the most important features, which each group fulfills. So I pass the word to the other Frank.
Thank you, Frank, and welcome from my side as well. Let's start from the history of smart glasses, where hinges are not an important part of the frame. Virtual reality frames contain large displays and their weight can exceed 200 grams. These frames are usually used statically, for example, connected to a PC. After use, they're stowed away on the shelf, so no need to be folded to a compact pocket fitting size. Currently, no spring hinges, no hinges are necessary. But also in this market, the trend is to reduce the size and the weight of the eyewear in order to optimize the comfort. As you can see on this picture, from now to the future, the size is really much minimized. So a hinge will become more important in this VR market as well in the future. Let me show a small benchmark of the weight of glasses. The more the weight increases on the eyewear, the more the hinges get stressed. Light reading frames are only 9 grams of weight. Ophthalmic frames can reach up to 15 grams, and large sunglasses at a maximum of 35 degrees. This advanced requirement on the hinges show that if the weight increases due to integrated electronics, you have to be aware. The weight of smart glasses is highly increased by the installed electronics, acoustics, and optics. So their weight can reach 40 to 100 grams easily. And the hinge can diminish this weight feeling to the wearer by optimizing the pressure on the head, as Frank already mentioned. The hinges have the essential function to hold the frame safely on the head of the wearer anyway. To keep a high quality of production, some hinge basics have to be fulfilled, such as tight tolerances in the production, the choice of the right material, such as nickel silver, which is the most common material in the optical industry, but also bronze, stainless steel, or titanium. The construction of spring hinges and regular hinges is depending on the size of the frame. So you could use a 1-barrel construction, 2-barrel for wider frames, or even a multi-barrel for really wide temples. Since the hinge is the visible decoration of the frame, the surface quality is really important. And the optician has to adjust the frame to the individual wearer's head. So this inclination ability is very important. And last but not least, the essential part of any hinge is the screw. So what options do you have? The first group we are talking about are regular hinges. Regular hinges exist in multiple shapes and forms. You can use regular hinges for metal applications, to be soldered or welded to a metal frame. For lightweight frames, you can use titanium hinges. There are existing combination frames with metal front and plastic temple, or vice versa. Or you have a full plastic frame with plastic front and plastic temple. For exotic materials, the hinges could be riveted. And as I already said, for wider, massive frames, multi-barrel hinges are used. To optimize the function of regular hinges, the movement control can be added. Without movement control, hinges tend to get floppy. So the heavy temples, especially of smart glasses, may fall onto the lenses. In the worst case, the temple even can get lost if the screw falls out. This movement control can be achieved by overmolding with plastic. Either you can overmold directly the hinge eye, as you can see here, or you can overmold the shaft of the screw. Let me show you a small demonstration video. Plastic on the screw shaft can overcome a certain amount of tolerances in the hole of the hinge. And if you screw it in, the plastic will flow in between the 1- and 2-barrel hinge, controlling the friction. Without this plastic, the temple will get floppy after a certain while. And with plastic movement control, the temple function stays smooth over the whole lifetime. The task is to fix these regular hinges to your mainly plastic smart glasses. So we recommend to use a hinge mainly meant for riveting, but to be screwed with, to be bolted with screws to your frame. And Frank can evaluate the regular hinges in concern of the secrets.
Yeah, so let's see what major features for smart glasses are fulfilled by the regular hinges. Due to their size, for sure, they are not heavy, but the weight can even be diminished by using, for instance, titanium. Another feature, important one, is the optimum movement, which Frank now described. For sure, this feature is realized only in combination with a plastic coating, either on the hinge barrel or by the plastic coating on the screw. Only with these small additional features, you reach the goal of a perfect movement over a lifetime of a frame, even also if the screws are not totally assembled. I can compare this maybe to a Mercedes door, which closes and opens in a high-end way compared to a cheaper car. The third feature is the long-lasting function, which should be granted in an appropriate mainly metal hinge, and which is used in the relevant spectacle. Finally, these hinges are not suitable to be used in applications where data are transferred to the front part of the frame. All these hinge solutions are orientated to a smARt function only on the temple.
So the second big group of hinges are the spring hinges. The theory of operation of spring hinges is to have two stable positions, a closed storing position and an open wearing position. The movement in between and beyond is spring-loaded, as you can see here. This is the storing position, the closed one. Switching to the open position and beyond, the overextension, spring-loaded. The main features of spring hinges are that the spring hinge can be overextended, as I just said, what favors comfortable putting on and wearing the glasses. The spring hinges ensure a perfect fit on the head, and the temple will stay in the position you choose. To keep a high standard of production, necessary tests have to be made in regular cycles. For example, the endurance test. The whole movement, opening, closing, and overextension is done 25,000 to 50,000 cycles without failure. For adjusting the frame at the optician, the inclination is tested till breakage of any part. The opening angle is measured very well. And when it comes to connecting metal parts, the stability of this connection is also controlled. Last but not least, the torque of the screw is controlled to guarantee perfect fitting. A lot of variations of spring hinges exist on the market, such as loose spring hinge boxes to be soldered onto metal parts, onto metal temples. For lightweight frames, the spring hinge box can be out of titanium for welding or laser welding. You can have pre-assembled spring hinge boxes on a wire core to be inserted into plastic temples, or a loose spring hinge mechanism for fixing into metal temples by a screw. The latest construction shows spring hinges to be just clicked in, pushed in into plastic temples without any fixing screw. And of course, there are more exotic constructions with 360-degree opening angle, for example. Let's concentrate on 3 examples of spring hinges, which are ideal for smart glasses due to their assembly by screw. For example, a small one-barrel slim flex mechanism, or a special carbon fiber case with 2-barrel mechanism. This picture also shows the variety of front hinges available to be fixed to several front materials and constructions, such as plastic, riveting for delicate materials, or screwing. And the third one is a very short and compact spring hinge to be 100% hidden into your frame.
Yes, evaluation of these flex solutions for smart glasses. Let's see what major features are related here to fulfill. One major aspect of spring hinges is the comfort. The spring is in fact not only a wow factor or a gimmick, but a real benefit for the wearer. With a correct spring hinge, we can increase the comfort dramatically. Another related feature to smart glasses of spring hinges is the exchangeability. In fact, the repair related to smart glasses is not only meant to handle, it's mainly related to handle the electronic device. If hinges are mechanically installed, if hinges are mechanically installed with a screw, a disassembling is easily possible. Of course, good spring hinges ensure that the smart glasses can be worn for a long time. Considering the present category, we still cannot fulfill a data transfer. All these hinge solutions are orientated to an independent smart function only in the temple.
So if data is transferred between temple and front, the hinges play a major role for the perfect smart functionality. Reasons for exchanging data might be supplying a display in the front of the hinge of the frame with signals provided by the electronics in the temple, or leading the power from the battery in one temple to the CPU in the other temple, or just synchronizing audio modules in each temple. And if only the temple of the smart frame is loaded with electronics, as Frank just said, a regular hinge or a spring hinge, as shown above, is completely sufficient. But in case data, current, signals, etc., is transferred between temples and front, the task is to have a link which connects the components of the glasses, supports a constant signal flow between temple and front, and protects the transferring electronic components, such as cables or flexible printed circuits. A possible solution for handling these signals through the hinge are with contact pins. The pins are positioned in the area of the hinge and only provide a closed circuit, a contact, if the temple is put into the wearing position. The big problem is contacts can get polluted or accidentally get touched, but may cause a short circuit in the worst case. Another possibility is to have a cable feed through. In most cases, it's not feasible to lead the cable through the middle of the hinge axis, which would be the neutral fiber of the hinge. So this picture shows the cable being led through the pivoting point, through the neutral fiber of the hinge, which provides the perfect shortest way. Only in this neutral fiber, the length of the cable remains constant in any position of the temple. But if the cable is positioned below the neutral fiber, what is more feasible in reality, its path is longer in the folded position than in the wearing position. So if the cable is positioned below the hinge, its path is much shorter in the closed position than in the wearing or in the overextended position. If the cable is positioned below the pivoting point, two problems occur. The cable is too short. In the folded position, it will be stretched or even torn if the temple is folded. You can see the tear here. And if the cable is too long in the wearing or in the overextended position, what may cause the cable from throwing loops and getting pinched between temple and front. Make it damaged this way. To compensate this elongation, you need a buffer area. So the cable can be stored in this buffer area in case it's not needed. This picture shows an example of the market with the buffer area on a real smart frame right behind the hinge. And to protect the cable from accidental contact, of course, you need a shield, which ideally is integrated into the hinge, to the temple, or the front. If you want to stay close to the neutral fiber, so the cable has to be fed through the hinge, like this. But the disadvantage is to exchange or repair the electronics or the hinge. It's not easy because you have to disconnect the electronics from the cable, feed the cable through the hinge, repair it, feed it back, and connect it again. So to solve all these above-mentioned tasks in one patented construction, OBE developed the smARt link, which is invisible from the outside, discrete from the inside. The smARt link integrates well into your frame design. The cable or FPC can easily be inserted into the smARt link, and later disassembly and reassembly is possible in case of any exchange or defect. The smARt link also covers and protects your flexible printed circuit in each position, also in the closed position of the frame. And by dividing the articulation angle of 90 degrees from open to closed into 2 times 45 degrees, the FPC is stressed less. So no harsh 90-degree bendings, but 2 times 45 degrees. In combination with a smooth cable routing and large radii, the cable is prevented from any damage. The smARt link is also easy adjustable in the width to fit your customer's frame. So to sum it up, the smARt link guides your cable, avoiding friction and kinking. The electronic connection is guaranteed in each position. 2 space screws, as I showed you before, grant a fixed system and a smooth movement. The cable is protected from accidental access in each position of the temple. The construction can be adjusted in different cable widths, and only small elongation of the cable path during the hinge movement, so you don't need a buffer area. Optionally, the smARt link can be equipped with 2 spring-loaded pushers to guarantee 2 stable positions of the temple, open and closed. These springs and pushers guarantee this snap-in effect on the end of the movement. So stable wearing position leads to a stable closed position. Let me show you some dimensions we plan to produce a smARt link in. And Frank can summarize the evaluation. Okay.
Yes, we can summarize in 4 major aspects. The smARt link is really like a Mercedes door, or even maybe like a Rolls-Royce, because we have even 2 space screws implemented in the construction. Thanks to these screws, with the blue plastic, the smooth movement and the long-lasting feature is granted. Then, as Frank explained very carefully, very deeply, it can be easily exchanged thanks to the patented construction with an open groove for the cable. and of course, the safe data transfer is guaranteed by the whole system. So in the following short video, you can see the application of the smARt link. So I saw that during the presentation, some questions came up from you. Let me see what question we can have. One is related to the material. So what materials, I think Ulrich, you might answer this question. What materials do you consider the best for hinges in smart glasses?
Generally, depends from the requirement from the customer, also from the stability and the size. I think that Frank mentioned we have 3 or 4 types of material. You know, nickel silver is a standardized material, also bronze and titanium and stainless steel. I think we can recommend it for this stability is the best solution in stainless steel for these dimensions.
Thank you, Ulrich. There is another question which I just see. What is the minimum size for a hinge in smart glasses?
You know, a standardized dimension. Let me look. We have a small micro steel only for demonstration. What dimension we have? You see, this dimension is 1.82 millimeter at the width, but this could not good solution for smart frames. We have some bigger that we can adjust or adapt. This is another. Have a look. A multi-barrel that Frank also mentioned in the presentation. It's much more stable. You see this, we can rivet it, and this from nickel silver, but also could happen in titanium. But the most effect is, I think, the smARt link in stainless steel.
I have several questions relating to the slides, which, if they will be available, for sure, we will send the slides to you after this presentation. So we have your contact data, so you will get the presentation as a PDF. And additionally, we will put this session also in YouTube. So we'll send you also the link. So I have another question here, which is more from the product side. You mentioned smooth articulation. How does it work to keep smooth? How does it keep smooth in the lifetime of a data frame? Maybe Ulrich?
Yes, depends also from the construction width, the stability, and also the tolerances from all the material. You know, plastic and stainless steel needs to fit together, and you see the plastic coated screw fit in a very good complete combination with a smart link. And when you open and close it, I think 10 or 20 times per day, and the life cycle is 25,000 movements. I think the lifetime could be 4 years. I think it's good enough for this kind of system.
So thank you, Ulrich. I have another question, maybe for Frank. What's the real difference between a spring hinge and a regular hinge for my application?
Well, of course, we don't know your application especially, but in general, I can say on the regular hinge, especially with movement control, the movement of the temple is controlled and smooth over the whole opening angle from closed to wearing position. Let me show you a slide. That is, in each position, the movement is controlled and smooth. In comparison, the spring hinge, you have two stable positions, the closed and the wearing position. And in between, the articulation of the temple is very freely. And you can overextend the temple a certain amount of degree, and it will come back spring-loaded to the wearing position. So this is the main difference.
Okay, thank you, Frank. I think this is a question which is relating to spring hinges. Just popped in. Can the spring force of spring hinges be adjusted? Is it variable? Maybe Ulrich?
Yes, generally. Also in the past, we have that kind of questions. How can we adjust different spring? We have different spring forces, soft, middle, and strong. And when we prepare a new system, we load it with such kind that the request or the requirement from the customer, and fit it together with different spring types. And then it depends also from the weight from the frame and also from the construction size.
Understood.
We can recommend it. We have 3 types of springs.
Okay. And then I have another question, maybe for Frank. What temperature can your components stand?
That's a very important question. For on spring hinges, the most delicate component is the spring itself, which can stand up to 280 degrees centigrade. And your electronic components won't stand a higher temperature, so I think it's no problem using a spring hinge. Regular hinges are limited by the plastic coating of the movement control, which can stand approximately 200 degrees. So this should be higher than electronics as well.
So if I have just a look, I don't see any more questions. For sure, you're free to contact us separately. So I think it's time also to finish the webinar. Let me finish this with a quote. An American businessman once said, big doors swing on little hinges, meaning the choices and decision one makes in life produce a much larger outcome. We say big smart glasses should swing on the correct hinges. And of course, we recommend OBE. Otherwise, you can see here the result. So thanks for your interest. We'll send you the presentation as it was asked several times as a PDF file, plus the link of YouTube. If you have any further questions, please feel free to contact us under the address which is mentioned here. And then bye-bye. See you in presence or virtually, maybe through smart glasses. Thank you very much.
Bye-bye.
Bye-bye.